the diagram as well. Okay, once again, hypotenuse, leg, congruent triangle theorem is if the hypotenuse, you need two things to be congruent. You need the hypotenuse, and you need the A side, also known as a leg, okay, are corresponding and congruent in both triangles. And if they are both, if the hypotenuse and a side, or also known as a leg, or corresponding and congruent in both triangles, then the triangles are congruent. Let's explain first a little bit. So we're going to explain one thing about a right angle. Okay, there's a special thing about a right angle here. Let me rewrite this. So the thing about a right angle is, whenever you have a right angle, the opposite side, okay, the opposite side that's facing away from the right angle will always be called the hypotenuse. Okay, so once again, you can only have an hypotenuse if and only if you have a right angle. So here, once again, you have a right angle here. So now you have a right angle, then you know that the opposite side of that angle will always be the hypotenuse. And we're going to practice that more. And in the assignment, I want you to draw each problem. That's the requirement for this. If you do not draw it, once again, this announcement, if you do not draw each triangle, then I'm not going to accept your work. And this is going to be really strict compared to the other assignments that I've been kind of lenient on. Okay? Only because of this fact alone. What else? Okay, so here, we're trying to prove that if triangle 1 here, how is triangle 1 congruent to triangle 2? Okay. I know it's already cluttered with facts here. So here, once again, our theorem is hypotenuse, leg, congruent triangle theorem, right? And our lesson is about is congruence in right triangles. Here we have right triangles, right? So this pertains to the lesson itself. Since we have right angles, or if we have right angles, then they're considered as right triangles. And here the theorem says hypotenuse, leg, congruent triangle theorem. If the hypotenuse and a side, or also known as a leg, are corresponding and congruent in both triangles, then the triangles are congruent. Here, do we have an hypotenuse that are congruent? Yes. Here, we have an hypotenuse. How do we know we have an hypotenuse? Because hypotenuse is always the opposite side of the right angle. Okay. So now here, you can see that the congruent is what the hypotenuse is congruent. Why? You know that the hypotenuse is congruent? Because of the 3 tick marks here indicate corresponding and congruent to, indicating that the hypotenuse are both congruent to each other, right? And then here, this is another side that is congruent, yes. Or you can say that, not side, we can say the leg. This is the short leg and this is the long leg. That's how it's being represented in the book or in geometry. Once again, the leg is also known as a side. Yeah. So just giving you that as a. And how do we know that the leg, these 2 legs are congruent? They're congruent because of the tick marks here. Okay. So here it's showing that these 2 hypotenuse are both congruent with the tick marks, right? And here we know that this short leg is both congruent because of the tick marks, right? So since we know that an hypotenuse and a leg is both congruent on both of the triangles, which the theorem states that if the hypotenuse and a side, or also known as a leg, are corresponding and congruent in both triangles, then with that the triangles are congruent. Okay. So here, these 2 are congruent due to the hypotenuse. What's the hypotenuse? I misspelled it. With the hypotenuse, leg, congruent triangles theorem. Okay. Once again, use the right angle as a guide, right? Opposite of the right angle is the hypotenuse. You can just use and H, short for hypotenuse, right? Here, in the next one here, I want you to see which out of the 4 is your hypotenuse, or 3. The 3 segments are your hypotenuse. Do another poll. Is it segments DE, DF, oops, or segment EF? Okay. Okay, we'll show a response now. Nice response rate. I like. So now here, our next one here is hypotenuse. Here is DF. Once again, how do I know that it's my hypotenuse? Because it's the opposite side of the right angle, right? Now we have one part of the theorem, right? We have the hypotenuse that's congruent for the hypotenuse leg. Now we just need a leg to be congruent, or once again, the leg needs to be another side that is congruent, right? So here, this side is different from the first example, right? The first example, what was the side that's congruent? It was the short leg, right? Now here is not the short leg that's congruent, it's the longer leg, right? The longer leg is congruent to each other. So it doesn't matter which side, as long as you can dictate which out of the 3 is hypotenuse, and the 2 sides are, whichever side is congruent will help you determine if they are a leg that's a congruent. It's a leg, or once again, you can just call it a side. I don't want you to kind of get confused. It's just based on the theorem. And also, it's another way to name a side as a leg in a triangle. So now we have a hypotenuse that's congruent, corresponding on both triangles, in triangle 1 and triangle 2. And in triangle 1, we have AB is congruent to segment EF, which is also a side on that's both corresponding because they're both the long legs part of the triangle. So now you can state that triangles ABC will be congruent to triangles D, E, F. Why? Because we're going to be using D. Sorry, I mean, I drew too low. Whoops. They're congruent due to the hypotenuse leg congruent triangles theorem. You can also use a shortcut for hypotenuse leg using HL. But once again, I like abbreviation.